Hello, today we are going to be talking about power of a power property and quotient of a power property. Okay, so whenever you raise a power to another power, you keep the base and then all that you do is you multiply the exponents. So if we had a to the m all to the nth power, you would just multiply your exponents. So you just multiply m times n and you would just keep your base the same. Okay, so like looking at this one here, we have 5 to the 4th, all to the 2nd. So our base is 5, so we're going to keep our base as 5. And then when you're taking a power to the power, you just multiply your two exponents. So 4 times 2 is 8. So your answer here is 5 to the 8th power. All right, next one. So 6 to the 7th power, all to the 9th power. Your base is 6, so you're going to keep your base and then just multiply your exponents. So 7 times 9 is 63. All right, looking at the next one. What's your base? Your base is x. You're taking x to the 3rd, all to the 5th power. So again, the rule is you just multiply your exponents. So 3 times 5 is 15. All right, and then letter D, again, you have y to the 2nd to the 3rd, so you keep your base, so you're going to keep y, and then just multiply your exponents. 2 times 3 is 6. Okay, now let's say you have a bunch of stuff within your parentheses. Like now we have a times b all to the mth power. So what you're doing is if you have a bunch of stuff inside of the parentheses, you first need to simplify whatever's in the parentheses first. So like here, you won't be able to take a times b because they're not going to be like terms and we can't do that. However, you can do your distributive property. And when you do your distributive property with an exponent, it goes to all of the exponents within that parentheses. So it would be a to the m, b to the m. Okay, so let's just do a couple of examples. All right, so notice how this time we have two things within our parentheses instead of just one, and it's already simplified. You can't do anything else with the 4 and the y, but we're taking it to the 3rd, so you have to do your distributive property. You're going to take 3 to the y and 3 to the 4. And all that you're doing is you're multiplying the exponents. But do the 4 and the y have any exponents? They do not, but remember they do have imaginary exponents. They do technically have 1s. Okay? So if your term does not have an exponent, just put a 1 in its exponent so that then you guys know what you're multiplying by when you do your distributive property. So your bases are still 4 and y, so you're going to keep 4 and y in your answer, and then you're just multiplying your exponents. So you're taking 3 times 1, which is 3, 3 times 1, which is 3. So 4y all to the 3rd power is 4 to the 3rd y to the 3rd. So the distributive property with exponents is you're distributing it to only exponents. You're not distributing it to your coefficients or bases like we're used to whenever we're solving equations. It just goes to your exponents. Okay? So look at B. So I can't simplify x or y. Everything is already simplified. And when you're taking this to what the power, again, you're keeping your bases the same, so you're still going to leave x and y in your answer. It's just you're going to distribute this 3 to all the other exponents inside. So we're going to have 3 times 2, which is 6, and another 3 times 2, which is 6. So x to the 2nd, y to the 2nd, all to the 3rd is x to the 6th, y to the 6th. Okay, look at C. Notice how everything is simplified inside, so you're just going to keep your base. So your base is 2, and then you're just going to multiply your exponents. So 3 times 6 here is 18. So your answer is 2 to the 18th power. All right, so let's try D. so negative 5 and m are our bases here, so we're going to leave those the same. And all that you're doing is you're going to multiply that 2 to its exponents. So even though there's no exponents showing, remember you can still put 1s here. So 2 times 1 is 2. 2 times 1 is 2. So it's going to be negative 5 to the second, m to the second. All right, so let's try the next one here. So I see that I can't simplify anything in here, so I'm just going to drop down all of those numbers. So negative 3, p to, or I'm not going to do the exponents yet, sorry. I'm just going to do my bases. So negative 3 p cubed. And now to get my exponents, I'm going to use my distributive property, and I'm going to multiply this 3 to all of the exponents on the inside. Again, though, negative 3 didn't have an exponent, but technically it has that 1 there. Okay, so just remember, you're leaving everything that is within that parentheses, so you're just dropping down all of their bases, and then you're just going to take that outside number and multiply it times all the exponents. Okay, so let's do that. So 3 times 1 would be 3. So there's going to be 3 as your exponent with your base of negative 3. P to the 4th to the 3rd, that would be 4 times 3, which is 12. And then our Q, so Q to the 0 to the 3rd, 0 times 3 is 0. And from what we learned yesterday, anything to the 0 power equals 1. So technically, we're going to leave this 1 here, or we're going to leave the q to the 0. So our q to the 0 here is going to drop because that just equals 1, and as we know, 1 times anything is anything. So our simplified answer is just going to be that negative 3 to the 3rd, p to the 12, and that's your final answer. All right, and then now looking at F, so I only have 1 base here, so that's nice. So I'm just going to drop down my base, and negative 1 times 3 is negative 3. And from what we learned yesterday, you cannot have negative exponents. So this 8 to the negative 3, if we were to put it over 1, it's technically upstairs right now. And if it's not happy upstairs, you have to take it downstairs. So the new simplified would have the 8 to the 3rd, because now it's happy, downstairs. And then if there's nothing upstairs, remember that there's still technically a 1 there. So 8 to the negative 3 is the same thing as 1 over 8 to the 3rd. And that is your simplified answer. All right, so see if you guys can go ahead and do G and H. So go ahead and pause the video. Go ahead and do G and H, and then press play when you're ready for the answer. All right, so you guys should be done with G and H, so let's see how you did. So your base here was R, so you should have left the R in your answer. And then a power to a power, you're just multiplying. So negative 6 times negative 3 is a positive 18, and that was your answer. Moving on to H, so we have 2 of our bases here. We have a 4 and we have a T, so we're going to leave that in our answer. And then you're going to distribute this 3 to all of their exponents, and you're going to multiply. So 3 times 2 is 6. Negative 7 times 3 is negative 21. And you guys should have realized that T is not happy. He has, or she has, or they have a negative exponent. So if they're not happy upstairs, you got to take it downstairs. So your simplified answer, 4 to the 6th power was happy upstairs, so you're going to leave that upstairs, and then you're going to take that T to the 21st downstairs, and then it becomes happy. So that is your final answer. All right, so I wanted to do the last one together because notice how I can simplify first. Okay, a lot of students like to try and move this 2 with all of these terms, and you're just making your life harder if you do that. So remember with equations, if you could simplify first, you had to simplify before you start solving for x. We're going to do the same thing with exponents. So if I can simplify anything, I'm going to simplify it first and then work with everything else I have left. Okay, so from what we learned on Wednesday, act like that 2 isn't even there, okay? And when you're just multiplying with exponents, you multiply your coefficients like normal. So 3 times 2 is 6. You keep your base the same, so our base is x. And then when you're multiplying, what do you do with your exponents? You just add. So 2 plus 3 is 5. Now look how much easier this looks. Okay, I simplify the inside of my parentheses to get 6x to the 5th, and now I'm going to take that to the 2nd power. Okay, so again, when you're taking a power to a power, you're just multiplying. So you're going to take your 2 times your 5. Remember, we technically still have a 1 here on that 6, so we're going to take 2 times 1, and we're going to get 6 to the 2nd, x to the 10th. And that is your answer. So these can get pretty confusing. The thing that happens the most that students forget is that there is technically an exponent on your coefficients. So please just remember to put that 1 there so that when you're distributing, you don't forget to distribute your exponent with the coefficient. Okay. All right, moving on to the back side. So now we are going to be talking about some quotients, okay? So we're just going to do some basic product of quotients with some simplifying that we need to do first, okay? So looking at this one, notice how I have the same base in the numerator. So that means that I can simplify my numerator first before I do anything with the a that's in the denominator. So you multiply your coefficients like normal. So I have a 1 times a 10, so that's still 10. You keep your base the same, so you're going to keep your a's. And then remember, guys, when you're multiplying, you just add your exponents. So 4 plus 3 is 7. Okay, so now I just have 10a to the 7th over a. So remember, whenever we are dividing with exponents, the rule is you're not adding anymore your exponents, you are subtracting, okay? So here I have 10a to the 7th over, remember this can be a to the 1st. So if I see my same bases here, so I see my bases of a's, I'm just going to subtract my exponents. So 7 minus 1 is 6. My coefficients, there's nothing to simplify 10 with, so I'm going to leave 10 alone. Keep your base of a. And like I said, subtract your exponents. So 7 minus 1 is 6. So this answer is 10a to the 6th. All right, so let's go down here so that I can simplify first because I have same bases. So multiply your coefficients like normal. My only coefficient is 13, so I'm just going to leave that in my numerator. Keep your base the same, so I'm going to keep b's. And then when you're multiplying, remember you just add your exponents. So 4 plus 4 is 8. All right, so the numerator is now simplified, but I have something in the denominator that I can simplify with. So I see same bases here, and we are dividing. So when we're dividing with exponents, remember you're just subtracting your exponents. So I'm going to leave my coefficient the same because I can't simplify that with anything in the denominator. Keep your base, and then 8 minus 1 is 7. And then 8 minus 1 is 7. All right, so let's try C and D now. So again, I can simplify my numerator first because I see multiplication. And I have same bases. So I'm just going to multiply my coefficients like normal. 7 times 1 is 7. keep my bases the same, so I'm going to keep my x's, and then add your exponents. So I have 5 plus, remember if there's nothing there, you put a 1, so 5 plus 1 is 6. Okay, so I can still simplify this one more time because I still have bases that are the same in the numerator and in the denominator. So look at your coefficients first. Can I simplify 7 and 10? Nope. So I'm going to leave 7 in the numerator and I'm going to leave 10 in the denominator. And then looking at my bases, so I still have x to the 6th and x to the 4th. So again, the rule is you are subtracting. So you keep your base the same. And notice since I have more x's in my numerator than my denominator, I have 6 x's and only 4 downstairs. I'm going to leave my x upstairs since I had more upstairs. And then I'm just going to subtract. So 6 minus 4 is 2. And that is your answer. All right, and then looking at D here, so same thing, I can simplify my numerator because they're multiplying. Multiply your coefficients like normal, so 12 times 1 is 12. Keep your base the same, and add your exponents. 2 plus 8 is 10. And then I'm going to leave that 16y to the 5th in the denominator. Okay, so this is not simplified all the way because I still see same bases, so I can get rid of one of these y's. So look at your coefficients first. Can I simplify my coefficients? Yes, I can, because 4 goes into both 12 and 16. So I can simplify this by dividing by 4. So 12 divided by 4 is 3, so that's going to be my numerator number. 16 divided by 4 is 4, so that's going to be my denominator. So you kind of just do it one step at a time. So 12/16 reduces to 3/4. And now we're going to look at our y's. So I have y to the 10th over y to the 5th. So I have more y's in my numerator, so I know that my y's are going to stay in the numerator. And then when you're dividing, you just subtract your exponents. So 10 minus 5 is 5. And that's your simplified answer. Okay, so now let's talk about power of quotient property. So whenever you have your quotient, so whenever you have your fraction and you're taking this to a power, so kind of like the power to the power, you are taking your exponent to all of the exponents in the numerator and in the denominator, and you're still multiplying, okay? So this would technically be a to the first, b to the first. So you're just taking m times 1, which is m times 1, which is m. So it would be a to the m over b to the m. Okay, so it's still kind of like the distributive property. It's just within the numerator and the denominator now. Okay. So for example, down here they use numbers. So you had 2/9 to the 5th power. So you're just, again, doing the distributive property to all of your exponents in the numerator and in the denominator. And you're just multiplying. So 1 times 5 is 5. You keep your base. 1 times 5 is 5. You keep your base. So this answers 2 to the 5th over 9 to the 5th. Okay, so now let's just do some examples down here at the bottom. So again, I see my fraction. I can't do anything with a and 6, so now I'm just going to take it to that power of 2. So again, your power goes to every single exponent on the inside, in the numerator and in the denominator, and you're just multiplying. And again, guys, if they don't have exponents, put the ones in there so that you don't forget to multiply it all, okay? So you're going to keep your base of a and 6, and it's going to stay numerator, denominator. And then now you're just multiplying your 2 times the 1, 2 times 1. So a over 6 to the 2nd power is a to the 2nd, 6 to the 2nd. All right, looking at b. So I have b to the 4th over c to the 3rd. I can't do anything to simplify it first. So in my answer, I'm going to leave my bases of b and c. And then again, when you're taking it to a power to a power, you are multiplying the exponents. So 4 times 2 is 8. 3 times 2 is 6. So this would be b to the 8th, c to the 6th. All right, C, I can't do anything with x and -9, so in my answer I'm going to leave the x and -9. So I'm going to leave my bases. And then again, you're just multiplying. If you're taking it to a power, you're multiplying your exponents together. So again, if they don't have exponents, put the 1s. So 1 times 2 is 2. 1 times 2 is 2. So that would be x to the second over -9 to the second. All right, so how about you guys go ahead and do D and see if you get the right answer or not. All right, so you guys should be done with D. If you're not, pause the video, but I'm going to go ahead and give the answer. So you cannot do anything with -2 and n, so you should have left -2 in the numerator and left n in the denominator. And then you are just multiplying your 4 times their exponents. So since they didn't have exponents, you put 1s there. And then your 1 times 4 is 4. 1 times 4 is 4. So you should have had -2 to the 4th over n to the 4th. All right, E and F are tricky, okay? Because again, I said that when you're taking power to a power, it goes to every single exponent in the numerator and in the denominator, okay? So like x doesn't have an exponent, so I'm going to put a 1. Y doesn't have an exponent, so I'm going to put a 1. Don't forget about the coefficients. Coefficients technically have exponents as well, okay? So that's why I'm telling you guys to put all the 1s here. Because then when you're taking it to the power of 5, remember, your power goes to all the other powers inside. So this time, we're not just taking it to 2 numbers, we're taking it to 3 numbers. So we're taking it to 3 bases, okay? So your x, 2, and y are going to stay in your answer. Okay, all of your bases and numbers are going to stay there. It's just your exponents that are changing. So when you take 5 times 1, that's 5. And then same thing down here. So 5 times 1 is 5, so that would be 2 to the 5th power. 5 times 1 is 5, so that would be y to the 5th power. A lot of students forget the exponent on the coefficient, okay? So please, please, please do not forget that. All right, so how about you guys go ahead and do F? So pause the video and then see if you get the right answer or not. All right, so you couldn't simplify anything, so you should have just went ahead and put all of your 1s within your fraction. So -5 or -5 to the 1st power, 3 to the 1st power, and b to the 1st power. So in your answer, you should still have your -5, 3, and b. It's just you're multiplying your power to all the other exponents. So you're going to take 3 times the 1, and that's 3. 3 times the 1, which is 3. And again, 3 times 1, which is 3. So your guys' answer should have been -5 to the 3rd over 3 to the 3rd, b to the 3rd. And that's it. All right, so you guys just learned about powers to powers. So when you're taking a power to a power, you're multiplying, and you're multiplying your exponent to every single power on the inside. And the main thing to remember is that if it doesn't have a power on it, you put those 1s in there so that you don't forget to distribute, okay? And as always, if you can simplify first, you must simplify first before doing anything else, okay? So let me know if you guys have any questions.